We're ready.
We're recording.
Oh, hi.
Heads up. Hi.
Hi.
Happy friend.
I am so, well, I'm good. I'm good.
Yeah.
It's sunny outside.
You know, we were supposed to record this like 3 hours ago. Remember, that's our original time.
About that.
Yeah, it's been an adventure since then.
I think for both of us. Because I've got some adventure. Tell me about yours.
Well, we had a goat break, and they were in our neighbor's yard, and the little girl fell in love with Timmy, and I think wanted to keep him, wanted me to say she could have him. And then our other neighbor came over and her water line broke, but the water line's on our property, so there's this big puddle. And so we were just like, yeah, go ahead, go dig, have fun.
Okay, wait. So was Ben like on board for giving Timmy away to the neighbor girl?
No.
Oh,
no one was on board. No.
Okay, I thought you said Ben was trying to give him away. I was like, what?
No, she wanted me to say she could have him. You know, like when little kids like.
Yeah,
no.
I can see that. Timmy is pretty awesome.
Yeah. What was your afternoon like?
Oh, wow. It's definitely not as exciting as yours, but my son came and touched my computer. He says, but I did say to save it, Mom. I guess it just didn't save. So I was in the middle of recording a video anyway, it's all good. I just had to redo it, but that's okay. Not as exciting as yours. So.
Well, just different stress levels.
Yeah.
Well, different kinds of stress. Like, yeah. I lost an animal, you lost a video. These are whatever.
Yeah.
Everyone is safe. Your video's redone. My goats are locked up. Like, we're good. I think my neighbor's figuring out her water thing.
I hope so, because that's kind of a nightmare.
Yeah, it was expensive. Her water bill's been expensive. And then she was driving down and noticed there was a puddle. So.
Which makes sense. Mm-hmm. I bet that's what happened. I told you about my friend's house that's another story, but
we'll save that for a different intro.
Oh, yeah.
Sorry, one of my dogs is in here with me today and he's being kind of loud and annoying. So
well, that's okay. I don't know. I hope I don't think my door's locked, so we might
Hey, look, my broom is still there though.
I know. I thought it was really funny because it's been there the whole time.
Yeah, and also I'm pretty sure I don't know. I guess I brought the vacuum in last. I didn't use it even.
Oh,
okay. It's just been there, just in case. I don't know.
It works.
Okay, so our story.
Okay, I've been looking forward to this because I got you gave me a little tidbit that it's about.
Yeah. So we're gonna go to the early 1800s.
Okay.
Okay. To India.
Okay, this isn't that long ago then, really. Okay, compared to what you were doing before.
Like 200 years ago. Yeah. So like 200 years ago, we're going to India. And okay, so in the early 1800s, the British forces defeated Tipu Sultan, who was one of the leaders of the Kingdom of Mysore. So this was the Mysore-Anglo Wars, which lasted 30 years at the end of the 1700s. So at the beginning of the 1800s, we were post-war. And so in the Kingdom of Mysore had been defeated and by the British. Okay, so the British side, well, not even the British. Okay, so they were half British, which was the East India Company. So the East India Company was represented by British India. But so they were basically like a satellite of England. Okay. So, and then also the Nizam of Hyderabad, and I didn't do a lot of research on them, but they were an Indian-based group that had aligned themselves with the East India Company, who were British. Okay. So they defeated the Kingdom of Mysore. And so that meant that now, essentially, Britain was in charge of, or had taken over the subcontinent of India. So we're in British India now. So it's India controlled by the British. Okay, so that's where we're at. So this was new, and so of course the British then needed to explore the subcontinent of India.
Absolutely, they had to look for
and they needed to survey their land. Like literally, we're going to be surveying their land in this story. Okay. So they started and of course they were motivated, like they wanted to see what they had, they wanted to see how big it was exactly, and just get a lay of everything that was going on. So they started this thing called the Great Trigonometric Survey.
Ooh.
Yes, and of course we know trigonometry is a study of triangles, basically,
right.
like how size and angles relate and all that kind of stuff.
Yeah.
So you can guess what's coming. Okay, and as a result, there were a lot of things. So it was the longest longitudinal arc of the time. So it was considered to be the most accurate and longest longitudinal arc. So a meridian arc, okay, so you know there's the sphere, right?
Right.
So the latitudes are like the ladders. They run horizontally, and the longitudes go this way, and they're all the same length. So they're all called a meridian arc because they cut the circle in half.
Okay, that makes sense.
So it was the longest meridian arc survey ever to that point. And so survey just means that they're like seeing what's it. Like they're taking all the measurements, they're drawing like an accurate map.
Are we talking like topography? Like
yes, yeah, like they're finding the topography.
Okay.
Yeah, and figuring out how far everything is and kind of laying it all out. It was the most accurate measurement. It's also one of the first times that they took into account, get ready for this, geodesic anomalies.
Okay, so let me see if I can, so geo, world, desic, slices, I don't know what science, anomalies, like events that don't always occur. So like, okay.
So large mountains. So large mountains affect the gravitational pull of the objects around it. That's what that's referring to, as a large mountain that's affecting the gravitational pull.
Okay.
So it was one of the first times that was deeply considered in their surveys.
Okay, interesting. All right, I'm on board. So, okay, well, I got another topic, but we'll talk about it. Okay, keep going.
Okay, so they started down at the base of India. So, you know, India is kind of triangular-ish. So they started down at the bottom in a valley, and then they went all the way up to the Himalayas.
Okay, and this is on one strip. Like they went one strip.
Well, it kind of, like, it was mostly one strip, but they did do some parallel and some cross-sectional a little bit. Yeah,
okay.
A little bit, but it was mostly from the tippy bottom all the way up to the top.
So they were focused on this one, like, meridian.
Yes, which went up into Nepal.
Okay.
And the Himalayan mountains, which is where Mount Everest is. So this is the story of how we got the height of Mount Everest for the first time.
Hey.
Okay, did you hear my dog just now? Little turd.
Yeah, it made it sound like, is he a robot? Because it made
He's flipping the cat bowl over.
Oh, that's
He's
what
like playing with the cat bowl.
Okay, well, maybe you're just not giving enough love. I'm excited about this because this has some great application. I'm thinking, but I don't really know.
Well, it's called the Great Trigonometric Survey, so there's probably some stuff. There's actually, sorry, I'm on my yoga ball again. This is awkward. There's actually more than I thought there was going to be when I started.
Because I can see the whole, like, yeah, okay. I'm not even going to pretend to know what. I can see even just, like, indirect measurement, like similar. Yeah, okay, keep going.
Yeah, there's a lot of things that end up happening. Okay, so one quick note about Nepal at the time. So Nepal, separate from India, up in the Himalayas, they do not allow outside visitors. And Mount Everest is on, well, now they do. Back then they did.
I was kind of, okay. They have like border control.
Huh?
They have border control back then.
And I didn't get into how they controlled their borders. That seemed a little off task from math history, but I was curious. I was like, how did you do this? But they're also up in the Himalayas, which is very mountainous. So they probably just have the, like, ability of being more knowledgeable about the mountains.
Absolutely. Yes. Do you find that as you're researching things that you just keep wanting to, like, research the next thing and then the next thing and the next? Yeah, that's.
Yeah. Okay. And I had to really edit myself, like, not directly in line with the story. Don't go down that rabbit hole.
I got you.
Okay. So anyway, so they called Okay, so I just thought this word was cool. So they had to enlist the help of surveyors that were native to Nepal, to the Himalayas.
Okay.
At one point. Most of our story won't be that. I just thought this was a cool side note. Those native explorers and surveyors were called pundits.
Spell that for me.
Pundits.
Oh.
Word of the day. And there were two really well-known ones, Nayan Singh Rawat and Krishna Singh Rawat, and they were actually cousins. Cousins. What was that word? I don't know where that came from. So they were actually cousins.
Oh.
So they helped when they were up in there. Okay. All right. So now we're going to introduce like our first guy into this, how this happened. So they were they wanted to survey all of India. Okay. You know, the British who stole it from India, but whatever. Yeah. Okay. That'll come up later too. All right. So George Everest was actually the second leader of the Great Trigonometric Survey. So he was the second. Can we call it TGS?
Yes.
Oh, TGS, Great Geometric Survey. Okay, so he was actually the second one. Okay, fun fact about him, he was born in 1790 and lived until 1866. He was 76 years old. Most everyone else in the story died like in their 30s or 50s. He lived to be 76.
Which means he was probably, I don't know. That's crazy for back then.
Yeah.
Really.
Yeah. Yeah, so a little bit about him. He was deemed the British, so he served as the Surveyor General of India. So when Britain took over, he got that role. He joined the East India Company. So remember, that was the British like army that was in India at 16.
Okay, so he was British.
Yes, he was British.
Okay, and at 16,
moved to India at 16.
To join the company, to be like the British, what? 16.
Yeah.
That's young.
Mm-hmm. Well, they had to go young because they died young. Yeah, like a lot of people in this story that I came across died in their 30s.
That's what you said. Okay, that makes sense. So, all right, I'm feeling it. Okay.
Okay, so he initially was the assistant to William Lambton of the GTS, but he was most known for finding this meridian arc. Like that was his like legacy. Like that was his thing.
But he was the second person to do it.
Well, no, it was like a 70-year project. It took a long time.
Well, it makes sense because it's like, yeah, okay.
Yeah, so it took his part where he went from the southernmost point of India to Nepal. So there was some pre-work before him and some work after him, which we'll get into. But his part, which just went from the southernmost tip up to Nepal, took 35 years.
Wow.
That was almost half his life.
So that's insane. So can you give me like some perspective on, I know this, I keep going back to like, I know this is a really long distance, but like any perspective on like how?
Yeah, 2,400 kilometers.
Wide?
And tall.
Oh, tall. Okay.
Yeah, so that's how long, tall, I guess. That's how long the path was. Yeah. And it wasn't very wide. Like he mostly just did along that one longitude. And I didn't write down what longitude like degree it was.
Yeah, that would be interesting. And were they only doing like whole longitude, like, you know, they're in degrees, right?
Yeah, it was parallel lines. Yeah, in degrees. It was mostly the one. Okay. And there were some shorter branches off that I think were, and we'll get into how they actually did the measurements, but I think those branches off were actually a result of needing to like get to that one. So it was like there was this long line and then there were like these little like rectangles off of it. Like if you look at the path, because well, and they were probably exploring some other things as well, but his part was just that meridian arc. Like he just did that part.
Okay.
35 years. And there was people after him and before him that did it.
Great.
Yeah. So, and then also fun fact, this is for you, Rochelle. I wrote this down for you. He stayed in this lodge in this town called Hathapaon, and which has a view of the Himalayas and is 7,000 feet above sea level. So it has a really beautiful view, and it's a lodge, and you can actually visit it today. It is covered in graffiti, according to the author of the article I was reading. Okay. But they've been there. But it was beautiful, and they called it the Logarithm Lodge.
What?
That's what they named it. You'd like that.
Okay, I do like that. I was like, okay, what is it that I'm gonna like about this?
Yeah, I don't think he named it that. Like, I don't think that was Everest that named it that, but yeah. Anyways, that's what they call it now, the Logarithm Lodge.
Very cool.
Isn't that fun?
It's very cool. Covered in graffiti. You can stay there still.
Yeah. Okay, so the survey. Okay, so this great trigonometric survey. It sometimes required a team of 700 people to do at a single time. 700 people.
I am just blown away. Like, this is, you know, we've got like satellites, and I mean, we've got like all these things now, like 700 people, 35 years of one person. This is intense. What was the prize they were after? Like,
just knowing the land.
Isn't that interesting? Like, do you think that there's something that we could focus on for, remember we were talking about the 5 years of like staring and like,
probably space.
Yeah. Oh, did you hear the launch didn't happen today? Anyway,
I heard. Yeah.
All right, we'll talk about that another time.
Yeah.
Okay, keep going.
All right. Okay. So he needed a lot of people to help him. But one of the things that he needed was, sometimes they were called computers, sometimes they were called calculators, but they were people that were doing like the math that was needed.
Okay.
So he needed like the best mathematician, right? Like, he needed really strong people.
Somebody that could do it.
Yes. So he went to the Hindu college, which is now called the University of Calcutta, and he got in touch with John Tytler, who was a Scottish medical officer and surgeon. So he was from Scotland.
Okay.
He came over because of the East India Company.
Right.
And he sailed to India in 1918 with his mom. And he stayed in India and began lecturing on math in 31 to 35. And then in 35, he moved back to London. So he was really only there like at the college for 4 years, which is super interesting when we go to the next thing. Okay. So one of his greatest legacies, so this is John Tytler, and I just thought this was interesting. His greatest legacy was he was arguing that not all Indian medical education had to be done in English. So he was an expert in Arabic. And he believed that English in India, despite the British rule, did not have to be taught in English. And he wrote letters, and he attended meetings, and he fought for it. Like, he taught himself Arabic over 14 years. He considered himself an Orientalist, so he had a deep appreciation for Far West culture. And he did not want to see Arabic be lost. So the belief at the time by the British company that was like running India at this point, was that Persian and Arabic were irrelevant and everything should be taught in English. And he fought to be able to do it. And obviously they speak other languages there. So like, yeah. So then he moved back to London. Okay. So he had in 35, and he actually died in 1837. So he was 47 years old.
Okay. Wow. Wow. But he, like, that was his mission. That's interesting.
Yep.
So he helped out for just a little bit of the time, though, you said, right?
Well, he actually never worked on, he taught math. So he taught math at the Hindu college. And he knew, and so, I don't know. So Everest went to him to say, okay, I need a calculator. Like, I need somebody that's really fluent in math and calculations and all that. So John Tytler recommended Radhanath Sikdar. I'm just going to call him Sikdar because I don't want to butcher that first name a million times. I'm not sure I got it. Okay, so he was born in 1813. So this was like 13 years after the war ended. He is Bengali. He is considered the first Indian modern mathematician and scientist. He started in math. So he is the eldest of two sons, and his brother was Srinath, and he also had three sisters. The family was poor, super poor, and they struggled a lot. But both brothers were highly intelligent, and they got scholarships. Both of them did. Okay. So Sikdar's scholarship went to his books. He got to pay for books and continue his studies. Srinath's scholarship went to the family to help them survive.
Wait. What?
Yeah.
What?
Yeah. Isn't that sad?
Well, so one of them gets to get smart, like gets to learn, and the other one gets to.
Yeah, I don't know how he kept getting scholarships or whatever. Yeah, so anyway, so Sikdar, we're going to continue our story with him for a while. So you can see it paid off, but like, isn't that sad and heartbreaking? Okay.
Yeah.
So one of the other things that Sikdar started when he was young was that he joined the Young Bengali group, or Young Bengals, I guess. I don't. Kind of sounds like a rock band. I'm not gonna lie.
I was actually thinking of like bangle bracelets when you said anyway.
Oh yeah. So they fought against social injustices of the time. So he was really politically active in working against social injustices.
That's awesome. Because and he was scholarshiped, right, to go to school. Yeah.
Yep.
Okay.
Yeah, his family had no money. Mm-hmm.
So super active. Okay,
at colleges. Yeah. So at 18 years old, our friend Sikdar, he developed a strategy for drawing the common tangent of two circles and was published in the magazine Gleaning of Science, where the editor credited him and said that he has never seen work like this before, and he did not change it at all. 18 years old.
What?
Yeah.
You said it was the common tangent, so like two circles with a line that they touch.
And like the tangent that they would share.
Point. Okay. What?
I know. Okay, and never been seen before. So without finishing his studies, he joined the Great Trigonometric Survey in 1831, led by Everest at the time. Okay, so without finishing his studies, he was there for 7 years and 10 months. So he went to college at 12 because he left at 19 and wasn't done.
What?
And so it was noted that he studied the classics of mathematics, like Euclid and all those like classic works, that are referenced. That's what he did, is he read those books and created new things.
What he could find at the library, right? I am serious. Like sometimes when we read these and learn about these things, it makes me feel so dumb.
I know, right? Oh, look at these great things. Okay, so he was 19 when he went to work for Everest. And he was paid 30 rupees per month. So I did a little translating. Okay, so today that would be 40 cents.
A month?
Yeah, so 30 rupees, if we were to get 30 rupees right now, that'd be the equivalent of 40 US cents. In 1830, 40 US cents would be like $10 a month. So still not much.
No, and for these great things, like his thinking math that has not been seen by anyone before.
Well, so he was originally hired as just a calculator. He was just like, here's some numbers, put it through a formula, do it. Okay. But he proved his abilities to be so great because he developed formulas to do things faster and more accurately that he joined the survey team and was the first Indian on the survey team. Everyone else is British.
Hot diggity.
Right?
Sikdar.
Go Sikdar.
Go Sikdar. Man.
Okay.
All right.
We're just now on page 2 of my notes, by the way.
Oh, mercy.
Mercy. Okay, so, but I think it'll go a little bit faster. All right. So,
I'm intrigued. Don't take I'm intrigued. I really am intrigued. I love this, actually. There's so much.
I had a lot of fun reading about this. It was very interesting.
There's not going to be a quiz for me at the end, is there? Because
no.
Okay.
I guess, actually. Okay, so so we know triangles in flatland, right? So we have triangles in flatland.
Yes.
So they are not working on flat land, right?
Oh.
And as we talked earlier, there are some anomalies that make it crazy. Yeah, so here are some things that they had to consider. The curvature of the earth.
right?
We often think about triangles on a flat piece of paper, but as you curve that paper, the triangle sides change. So they're really in like this like hyperbolic geometry land because it's not flat.
And all the angles don't add to 180.
Yes. Yes.
That's
so they had to figure out how to make the angle, how to make what they knew about triangles in flatland work on a curvature surface, which there was some work already on that.
Right.
Okay. Also, the Earth, by the way, non-spherical. It's not a sphere.
It's got a little wonky.
It's fatter at the equator. So it's not a perfect circle. It's actually like the equator is a little bit fatter. So it's a little bit like, because the poles are like pulling, you know?
Yeah, well, no, that makes sense. I can get behind that.
Okay. Well, we already talked about the gravitational influence of mountains. So they would drop a plumb line. So they drop like a string with like a thing to measure like what was straight down, but
Right.
the mountains would pull it. So they had to calculate that.
That's insane. I'm like, okay. Wow.
There's 2 more things on my list.
Okay,
We're not done with their challenges, my friend.
Oh, really?
Oh no. So also, when you are doing things from a long distance away, there's a horizon, right? Because the Earth curves.
Right.
Well, that means that the light is refracting. So the Earth is changing how the light is refracting. So when they're trying to look at like angles, the light can mess it up. Okay, so this is actually one of Sikdar. Sorry, all of a sudden I looked at his name and I like couldn't think of how to say it. One of his greatest contributions was how to compensate for the atmospheric refraction of light. Like he had strategies to like compensate for that, and and Everest also had ways to trace rays. So you know, like a light ray would go through something, but there'd be like a tree in the way. Like Everest developed a strategy to like deal with that, like as if they were removed.
Okay, this is
high level. And then also they have to consider how far above sea level they are. Like they need to know where they're standing, how far they are above sea level. So that's like the vertical change.
Right.
Yeah.
I'm just like kind of blown away. I'm still like, all the things are spinning. Now I know why you were like, I need a little bit more time.
I need to fix my notes up. Okay. So, okay. So all this is happening, by the way, in the 1800s.
That's where I keep going. I keep thinking to myself, what in the world? Like, I'm just impressed.
Yeah, so those are all of their things. So here's how they kind of did it. So I'm going to pull up a whiteboard here. Oh, sorry. Okay. All right, whiteboard. Share. Okay. So they would look at, I think my notes got messed up. Hang on. I slided down on my notes. I'm going to lose it. Okay. So they basically they started by triangulating a valley. So they took like this valley that was down at the bottom of India, and they figured out, so they would start by taking they would take 2 points that they knew and a third one that they could see. So they only had to measure one side. So they would measure one side, and then they would find the angle from one side to the other. So they would like find that angle of rotation.
Okay.
From 2 of the points, and then that would allow them to find the other 2 sides.
Okay, so they had the side X,
Mm-hmm.
and then they would find that angle of rotation from one of those points.
Yeah, they did it from both eventually. Yeah.
Oh, okay.
Yeah.
And then that helped them find the other 2 sides.
Yes.
Okay.
Yep. So then they would take they would take one side that they knew, and they would find, hang on, I gotta pause the recording real quick. So then they would take the one side that they knew, and so they now have 2 points, and they would set up a third point and do the same thing. So now they know this side, they would find these 2 angles, and then find these sides using the formula that Sikdar Sikdar, there we go. I keep mixing up the D and the K in my head. Created. And so then they would create another one, and then another one, and then another one, and then another one, and then another one. And they did that all the way up to Nepal from the bottom.
So can we talk, and you've got like links of 3 on there. Like, can we talk about like how far did they start with the valley? Like how far were the distances?
Like 100 kilometers-ish.
Okay.
Kind of depended. So they had this thing called a folding chain that was 100 feet, and it had to be super precise. And so they had like this chain that they used to figure out how many chains it was.
So that's similar to, you know, first downs, right? You got to have the chain.
Yep. They figure out how many chains. And it took them a long time to get the bottom part at the valley, because because everything was off of that. So calculation was super important, because if they're off here, then they're off for the rest of them.
And yes, so
and the air would only get bigger and bigger.
Yes, so that is attending to precision right there.
Yeah, that is intense precision. Now, I will say I never found what formula they used, which comes up because they actually never found any of Sikdar's work. Never.
He took it down with him, huh?
Yep. And especially the stuff, where we're getting to. Okay. So I believe that it was probably something like the law of signs, but messier. Like if you were looking at 2-dimensional land,
right,
this would be a law of signs problem. Right? But I don't know how they took in consideration all the other things. Wouldn't it be the law of signs?
Well, the law of signs, you have to know an angle and a side opposite.
Oh, no, it's a law of cosines. No? Yeah. You need to know 2 sides. So they knew 2 angles. Oh, no. It's, because you don't have the opposite. Huh. No, it wouldn't be law of signs. You're right.
Because you need to have one of the ratios in order for you to solve anything else.
Yeah, I was thinking because you had 2 angles and a side, but that side is between the angles, not opposite the angles. You're right. In law of cosines, you either need 2 sides in an angle or 3 sides.
Yes.
Well, now I really want to find his math, because I don't know what he did.
Well, good luck. He probably took it with him, because I don't. But interesting, and yeah, I'm actually now more intrigued.
Yeah, I don't know what he did, especially with all the other things, because he wasn't living in 2-dimensional land.
Right. So it was kind of like that non-Euclidean piece. So maybe.
Yeah, so it's something else, and I couldn't find it. Okay, so that's one of the things that actually comes up is they don't have his work. So Everest ends up leaving, and so they had 3 visible locations. Oftentimes they built towers to do that. So Sikdar never actually climbed the mountains. This man is next level, right?
Yeah, he's like, you guys go ahead, I'll just calculate.
Yep, pretty much. And he came up with all these ways. So basically they built, there's towers, and the towers are still there in India. You can go see them. They're still there.
But he climbed these towers, but he never went up to Mount
Yeah, so other people would build stuff and bring him measurements. Okay. All right, so Sikdar was obviously a master at all of these things that affected this. And he quickly, was rising in the ranks, and he was considered an officer. Right. In the British group, he was an officer as an Indian man. And he tried to leave the group to go do something else. And Everest blocked his transfer and said that he couldn't leave without his superior's approval, because he was so valuable.
He was the golden goose. Everybody wanted his math.
Yep. So eventually, after 20 years, he worked in the trigonometric survey for 20 years. Okay.
Okay.
And he finally was able to leave and he went and worked in meteorology. So he was the superintendent of the meteorological department. And he innovated new ways to calculate barometric readings. He was an innovator, this man. I know. Crazy smart. I know. Next level. Okay. While he was doing that, he was still a part of the survey, though. So he was doing the meteorological stuff, and he was still a part of the trigonometric survey. So the guy, when Everest left, this guy, Colonel Andrew Wog, took over and ordered Sikdar to find the heights of the mountains near Darjeeling, which is in the Himalayas. Okay, so Everest himself did not care about these mountains because they were in Nepal. It was when Everest left that Wog took over and was like, I want to know how big these mountains are. But they were in Nepal, so you couldn't actually go there.
So, because they don't let people in, right?
Because they're not letting in people. So they did have some people that could help them a little bit. But anyway, so and so Sikdar built towers, and they're still there. Okay, all right. So side note on Sikdar, in 1858, he noticed a technical error by one of his superiors named Thulier, and he wrote him a letter admonishing him. P.S. In 1858, British had just squashed an attempted rebellion by the Indian Sepoy. So a Sepoy is an Indian soldier serving under British rule. So there had just been this Indian group that tried to take over their country back, and then Thulier made a mistake, and Sikdar wrote him a letter admonishing his mistake. So in his response, I was not very understanding. So Thulier basically was appalled. He said, a native questioning a technical competence of a white man, and was appalled.
Okay, no way.
But Wog, the new leader, of course didn't punish Sikdar because nobody else could do what he did. So he didn't get in trouble. He had to write an apology letter to Sikdar, or to Wog, but not to Thulier. Okay. All right.
Oh my God. This is so much.
It's so much. Okay. So Sikdar does all this work, and he finds this peak. So this peak, it was originally called Peak 15, but they use Roman numerals, so it was Peak XV. So Peak 15 was at the top in Nepal, right? And he took 6 different observations of the peak. So he used like 6 spots to take measurements from. And he concluded that Peak 15 was the tallest mountain in the world, like right away. So he took this to Wog. Wog refused to announce it, didn't announce it, wouldn't announce it, didn't say anything for years. I think it was like 5 or 6 years. I couldn't really totally get a number, but it was like several years. And so according to the book Everest, A Mountaineering History by Walt Unsworth, which is considered the most exhaustive history on Mount Everest, so Wog wrote a letter to Henry, our friend Thulier, in 1856, right? That was all mad, that said, for some years we have known that the mountain is higher than any hitherto measured it. Yeah, I don't know how to say that word. In justice to my able assistant, J. Hennessy, it is proper that I acknowledge that I am greatly indebted for his cooperation in revising these computations. So Wog, the leader, wrote to Thulier, who was that jerk that him, and thanked someone else for figuring out how tall this mountain was and saying it was the tallest mountain.
He lied. He is naughty.
Liar. Okay, so why do I keep mixing up the D and the K in his name? All right, when Sikdar, did I get it right? When he figured out the measurement of the mountain, he found it to be 29,000 feet exactly. But he thought people would think that was an approximation, so he said it was 29,002 feet, so people would believe him. All right, so it was called Peak 15, right? So WOG did all this. There were a ton of names that were presented that were local, but WOG didn't like any of them or something, I don't know, and decided to name it Mount Everest. And Everest was angry. George Everest did not want the mountain to be named after him. He was back in England at the time, and he didn't want it named after him because Everest was something, it was a word that didn't exist in the Hindu language, and so it would be hard to write and to speak. And so he didn't want it to be named Everest. He wanted it to be named a Hindu name.
Which makes sense.
WOG went ahead and did it.
But why would he want to give Everest the credit in giving it his name? Why didn't he name it WOG or whatever?
I know, right? That part, it was, he didn't have like Everest was like this big, like grandiose character, I guess. Like clearly he like got stuff done, right? And he was a huge fan of Sikdar, and I think I got the impression from my little bit of reading that he had a lot of respect for the culture.
Oh, that's what it sounds like. And so he was angry, and at this time British were still in control of India. So
and Sikdar got completely taken out of the picture from WOG's perspective. Okay, so at some point in all this in 1951, there was actually a huge technical mathematical model or manual written called the Survey, and it was like how to survey land. And all the technical and mathematical information was written and contributed by Sikdar. Guess who edited the book?
WOG.
No, Hulier.
Oh, the guy that was...
Yes. So the first two editions, there was a preface that gave Sikdar credit. The third one, which came 5 years after Sikdar's death, had it removed.
Oh my gosh.
Right? Turd. Okay. So, but the Friend of India, the paper in India, called it robbery of the dead and was super angry. So good job. So some other things that Sikdar did, he protested against the exploitation of survey team members. So the team members, those 700 people, he protested against them being exploited. And he was fined 200 rupees. So remember, he was making originally 30 rupees per month.
Per month.
Yeah, he was making more then. But yeah, so he and so back in his young Bengal days, he fought for social injustices. So he kept doing that and fought against that. He ultimately became a math teacher, of course. Of course. For the Scottish Church College, which is now, it's associated with the University of Calcutta, which was previously the Hindu university that he attended.
Right.
Yeah, so it's all connected. But I thought it was interesting, it was called, and also the Scottish Church College, his professor that recommended him was Scottish. Way back when. So it seems like he has a lot of respect for his roots, and he also is credited with creating the modern language of Bengali because he wrote a magazine with his friend from the Young Bengalis, Perry Chand Mitra, that he co-published, and it was called Masik Patrika, and so that is credited with using a easy to understand version of Bengali.
Okay.
But it did have one reference where somebody said that it was a magazine for women, which got me bristled up. It was two separate things. One said they used Bengali that everyone could understand, and the separate resource I read said that it was a magazine for women.
So you're kind of putting those two things together to say simple to understand for women.
Which, maybe in the 1800s that wasn't, maybe they weren't educated, and so maybe it was them being supportive of it, giving them access at their level.
And there wasn't that political correctness of how you describe things,
maybe.
Yeah. We can
it was just, I was kind of I believe from what Sikdar stood up for, that he was probably doing it to provide access to the magazine. But this article written in like the early 2000s, 200 years later, called it a magazine for women.
Oh, okay.
I know. I was like, wait a second.
Marika, can I just tell you, like, why are all the mathematicians, where did all the mathematicians go? Why are they so mean? Like, he did all this wonderful stuff.
Mm-hmm. Well, so he's been recognized how do you say it? Posthumous. After his death. After his death. So he's been on a stamp. The German Philosophical Society made him a corresponding member, which is super uncommon in 1864. There was a book called written by John Key recently, in the 1900s, called The Great Arc, which is like all about this whole journey and all the players. And Sikdar does get credit in there. Okay, but fun fact. Okay, so you know how there's been no work. Haven't seen his work on calculating the height of Everest, right? So he died at 57 in 1870, and he retired to this place called Chandangarh, which is about 50 kilometers from Calcutta. Okay, I'm recording.
Okay.
Okay, all right. So Sikdar retired about 50 kilometers outside of Kolkata. So this article I was reading that was talking about Mount Everest and all this. So a writer, Ashish Lahari, went on a mission to go find Sikdar's house. So because he's considered like the modern father of math and science in India, right?
And he was really humble is what it sounds like too, which is actually really, I've got some things to say, but keep going.
Well, you can say it now.
No, say, because mine is like, keep going with this part.
More reflective. Okay. Yeah. So he went to, so Lahari went to go find his house.
Okay.
Which has been replaced by an apartment building.
Oh.
He did find a small street that was named after him. He went to go search for his grave, and he was directed to a cemetery. The grave did not contain an epitaph. And there are several Indian authors who have pursued like researching his life and recording his contributions, and they can't find anything.
Oh my gosh, so sad. So, okay, here's what I was thinking. So you know how when we talk about the Pythagoreans and how they were like doing things lots of people were doing things for the name of the Pythagoreans, right?
Yeah.
Like it just shows how like over the years people have become more divisive and like
and like how important it is to write things down for yourself.
Yeah, that's actually
like, make sure that there's a record of your, like, if you want the credit.
Yeah.
And I think this will be a theme many times, is like things get lost. Yeah, and especially before there was the technology that we have now.
And then just the not that it didn't happen, but like the backbiting, like, oh, I'm not going to give you credit, I'm going to give somebody else credit. Oh, you died, now I'm going to like throw you out the window. Like,
yeah. Well, and it's crazy that we can't, like, they can't really find like some evidence of his life right now. Like there's like paper trails of where he was, but there's no like, they at least in what I found, there was no work. Like they couldn't verify that he did the calculation. So he probably turned them in, and then that other guy redid them, like, all right. So a couple more things about Mount Everest, which I will now call Peak 15 forever.
Because let's just talk about the fact that this is like the British took over this country and then this happened, right? So like, and then, because, right? I had not thought about it, but like Everest is Mount Everest, like.
It's in Nepal. It's in the Himalayan, like, yeah. It's so the border of Nepal and China goes over the peak of Mount Everest.
Oh, I don't think I knew that.
Yeah, I didn't really know that. Okay. So okay. I didn't realize that. Okay, so Mount Everest is a huge draw for mountaineers, right? So they get a certificate from a mountaineering certificate that certifies how many feet that they climbed, right? Okay. So Nepal and China don't always agree on how tall Mount Everest is.
Like it changes on Wednesday versus Saturday or something?
Kind of, yes. Okay, so there's some disagreement over whether or not to count the snow. So without the snow on the top, it's like 29,017 feet. With the snow, it's 29,029 feet. So they like have some snow, which doesn't seem like that much snow. I don't totally get that.
I'm also thinking about that's not actually that far off from what Sikdar.
Yeah, no, yeah, that's the thing is like his calculations were like
so
pretty
close.
legit. Like,
whew.
Yeah, so anyways, okay, so Nepal doesn't have that much. They mostly export. They have some agriculture. They do some like making of clothing and stuff. So they don't have that much. So tourism is really important to them. So
Right.
China wanted them to use this, was putting pressure on the the Nepal government to take this lower measurement. But Nepal didn't want to. And so China ended up having to back off of it because the number of mountaineers going into the Chinese side, the north side, to climb decreased so much that they had to back off.
Because they weren't getting enough tourists coming in to like
enough climbers.
Because they want to go to the taller peak.
Yep. So Nepal has started its own way to find the most accurate heights now. And it is going to cost $250,000. But, so they're using a GPS. They're going to climb up to the top and put a GPS up there. And that helps with, you know, looking at gravity and the stars and all that. But they're also going to find 5 or 6 places for observation and triangulate using the same methods as Sikdar.
Oh, that's so cool. And so this is new? This is like something that's
well, 2015. So I'm assuming they've done it now. I didn't find a follow-up. Okay, but we were talking about how it can get lower. It dropped 2 feet in 2000, well, twice. So in 1934, that was measured to be a couple feet lower because there was a big earthquake. And where it sits, there used to be an ocean there, and it fell. But then it actually comes back up.
What?
Like, slide back up. Yeah, so it's moved up and down. So they're using GPS to do it. Okay. So that's cool. the story. But I have a fun little tidbit at the end. Okay.
I'm like I'm yours. I mean, like listening ears. Got them on. Well,
okay. So there are some that believe Mount Everest is not the biggest mountain.
Like right now, like people believe this.
It depends on how you measure it. So I'm going to pull a whiteboard back up.
Oh, mercy. Marika, you're always finding, like...
Okay, and I loved this part so much. Okay, so we have our, how do I clear all the drawings? Okay, so we have our Mount Everest, right? Okay, so here's our Earth, and I drew it not super great because this is the equator, right?
Okay.
So the equator is a little bit fatter than the rest of the Earth. Okay, so Nepal is above the equator, right? Like, not super accurate. So it's like kind of up there, right?
Okay.
Well, so Ecuador, and I'm going to draw it over here. So Ecuador is right on the equator, right?
Okay.
So they have a mountain there. Chimborazo is in Ecuador, and it's 2,500 feet above sea level, right? Just 2,500 feet, which is almost 8,000 below, or over 8,000 below Everest, right? At sea level. Unless you take into consideration the center of the Earth. So, because it's at the equator, and it is farther to the center of the Earth than it is to the top of Everest. So it is actually, if you're measuring from the center of the Earth instead of the average sea level,
oh my goodness,
more accurate because it's average sea level. The mountain Chimborazo in Ecuador is actually bigger.
What?
Fun fact, I have been really close to there because I went to Ecuador.
Did you?
And I got to go to the equator, and my physics and math nerd brain was so excited. I was at the closest point that a human being could stand to the sun. Well, because you could go to the top of Mount Chimborazo, I guess, without climbing, with staying in a car. I was at the closest point that a human being could be to the sun.
Okay, that is amazing. So okay, what was the difference then if we go to Chimborazo or whatever?
Okay, well, I'm gonna be honest, I forgot. It's in the scale of things pretty small, because I forgot to look it up. But
oh, that's okay.
just, so Chimborazo is 21 million feet from the center of the earth. So it's probably like 20,900,000 something, like it's pretty close, but anyways, it's pretty close, but technically it's the center of the earth. And I saw it. I was close.
That's amazing. So, okay, I mean, I don't think I ever had like realized, and maybe I did at one time, that the equator was like a bigger. I know that like the Earth's tilted, right? But like I didn't ever. But
and Ecuador is the only place that has like a really big mountain range, because it's the Andes, right? All the other places on the equator are flat, like close to sea level. So it's like significantly closer than anywhere else on Earth to being to the sun.
So tell me, that's incredible. Tell me.
Mm-hmm.
Who was the one that was trying, like, what's the word I'm looking for? The people that are trying to say that Everest is not the tallest mountain, are they Ecuadorians?
I think it's scientists being nerds, if I'm being honest. Like, I don't think any mountaineers are claiming they climbed the biggest mountain by doing to Chimborazo. Maybe they're claiming they were the farthest from the center of the earth or the closest to the sun. But I don't think there's any mountaineers that are like taking a strong stand, but it's just math geeks looking at the center.
I know. I mean, okay, but it is cool to think of like all the, that's like street cred, right? To have the tallest mountain, bring in the tourists or whatever.
And Quito is 10,000 feet above sea level, which is the capital of Ecuador. So it's like significant. Anyways,
wow,
it was pretty high up there. It was rough. Anyways, so Sikdar, kind of the mystery man. So he's like cool and humble and super smart and innovative and the father of modern math and science in India, but then like also no real evidence. Like super weird.
That is super weird. It's almost as if someone, like you said, must have taken his stuff and like ran with it themselves. But that's just crazy. Oh my goodness. That was a good story, Marika. I'm like, yes.
It was cool and it just kept unraveling. That's why I was like, need more time. Oh, I need more time. And then I had all these notes and I was like, I gotta organize them now. There's no like storyline. It was like
in the timeline, if you think about the timeline, you started, the very first was like early 1800s, right? And then that was like when they were talking about 1866. So like almost a 100-year time frame. And I just think about that mathematics, like, I don't know, I'm just blown away by people's perseverance, right?
Yeah. Well, and it came out of need. Like this was a made up need. Like they needed to know India, apparently. Right. But this thing they stole. But the math was what they needed to make that thing happen.
Yeah.
So it was like the solution to a problem. Sorry.
Oh boy. It's just really like amazing to me. I'm like in awe. I know I'm sounding really super cheesy right now, but I'm just like, when you start to contemplate some of this stuff.
Yeah, it was cool.
Yeah, and you did a really good job telling the story, Marika. I'm actually it was very good.
It was fun. Huh?
I needed popcorn to keep
right. I know. Next time we'll prepare with snacks. So
yes, exactly.
All right. Well, thanks, friend. That was fun.
It was fun. I'm so excited. I want to learn more about him. We should.
I know, right? I have more, and there's lots of recent articles. Like there was a lot of recent stuff compared to Pythagoras, for instance. Like there was quite a bit, and just the whole Nepal China tourism hike thing. Like that was like, what? Who'd have thought there was controversy over how tall Everest was?
Oh my goodness.
So, and I'll share the links. Like,
oh yeah, for sure.
So.
This was great. I can't wait to do this again.
All right. Bye, friend.